Hey, hey.
Hi, I'm Amber, by the way.
Oh, hi, Amber. Nice to meet you.
Nice to meet you.
All right. Hey, John. Hey,
Hello.
Sarah.
Hello, everyone. Can you hear me?
Yeah,
Yes,
I can hear you.
can hear you.
Okay, great.
All right. I was reading your agenda, so it looks like we have a couple minutes built in. What time is it for you, Espoir? Like
9
9?
of 9 p.m. Yeah, GMT
Cool.
here.
Cool.
Keenan. Rod. Hey, Sam.
Hello, I'm available.
Very mysterious today.
Yeah, it's 11:30 p.m. So
Oh,
the light
no.
is not making it, but I am
Wow.
here.
Oh my gosh, that's so dedicated.
Sorry about the light. Yes, I thought it was gonna be better. Hey, everyone.
Hi. Pretty good group. Okay.
I do have a hard stop in 30 minutes, fortunately. So if people want to keep talking, I can transfer the meeting to a new host. But yeah, otherwise I will start. Oops, sorry, I'm gonna close the window first. Yeah, so I'll start. Hi, my name is Cassandra. Oh, hey, Camille. Yeah, and I'm one of the organizers of Work on Climate, and as well as the Climate Fellows program. Sam here is one of the other organizers of Climate Fellows, and this is Work on Climate's volunteering with nonprofits program. And we're really excited to have Exaquest Carbon here today to share their volunteering opportunities with the group. Yeah, so I imagine everyone here looks pretty familiar, so I'm not going to do the whole Climate Fellows spiel, but yeah, so excited that people here are professionals who are looking to commit skills to helping out climate nonprofits. So I will pass it over to John or Amber. And if you could just introduce Exaquest as well as the opportunities, and then we'll open it up for the fellows to share their backgrounds as well as a Q&A with you. Yeah.
Okay. Well, so Amber and I are co-founders of Exaquest Carbon. I'll give you about a minute about myself. I was a practicing lawyer up until about 10 years ago. Went back to school to be a chemical engineer, and while I was at Stanford in the PhD program, Amber and I were in the same research group. So Amber was a postdoc, and we came up with this idea for carbon storage. Definitely tried to turn it into a for-profit, get researchers excited about it at Stanford. We didn't have a lot of success with that. And so we decided to found this as a research nonprofit. That's a way you can get scientific research done in the real world outside of a typical context. Amber, do you want to say a few words about yourself?
Yeah, sure. So my background is in the chemical industry before, well, I graduated about 15 years ago, and then I worked for Dow Chemical for a while and worked on ways of making buildings more efficient. And that got me into research, interested in research that could either save energy or that was just basically good for the planet in some way, shape, or form. And so I decided to leave Dow to get a PhD to work on a field of chemistry called catalysis, which basically makes chemical processes work better with less energy and less pollutants on a very high level. And I did that at Berkeley, and then I went on to do a postdoc on converting carbon dioxide into useful products at Stanford. That's where I met John. Both John and I worked on, different ways of converting the carbon dioxide into useful products, but we both came to the same ultimate conclusion, which was that those ways of dealing with CO2 are not going to scale fast enough and to the extent needed to solve climate change. They might be a drop in the bucket in the next 10 years or so, but we don't see them scaling fast enough. So I ended up going back to industry for a little while. I was a product development scientist at Clorox, but I also co-founded Exaquest with John, and I actually recently decided to leave Clorox to work full-time on Exaquest with John. I'm now the CTO. So I've been the CTO technically since like 2 weeks ago.
We're both parents, by the way.
Right.
Like I have a 3.5-year-old. Amber has like a 6-month-old. So like we're in this position of like not working full-time. We take care of kids a lot of the time, but we have enough time for a nonprofit. And we're both trained scientists, which is kind of weird. So rather than batter our heads against a problem we don't believe in, we pick something we do believe in. Let me just give you the high level picture of like why Exaquest is doing what it's doing. We have this problem of CO2 in the atmosphere. So any method we can use to remove CO2 from the atmosphere is positive. And when you look at the possibilities, photosynthesis is a really powerful lever for pulling CO2 out of the air. So growing trees, growing plants. What Amber and I realized when we thought hard about this problem was that nobody was paying attention to the decomposition side of things. So every year, photosynthesis will take about 200 gigatons of CO2, and it will turn it into biomass, like wood products, like these doors behind me. But every year, we kind of don't pay attention to that flux because it's offset by decomposing biomass. So rotting wood, rotting plant material, garbage, anything that can decompose is releasing CO2. Well, at a large scale, if you slow down those decomposition processes, then you will effectively remove CO2 from the atmosphere. And that's something that we believe in quite a bit. We think it's possible, but we don't see a lot of other people working on it in an academic context. So when we went to Stanford, and I remember talking to somebody like Arun Majumdar, who used to run ARPA-E. I was like, Arun, what if we just like stored biomass, like crop residues, wood chips, and stored it and prevented it from rotting? And he was like, are you going to turn that into a business or something? Like, how's that going to make money? And my thought was, well, you might be right. Maybe it's not the best business pitch of all time, but what if it works? What if this is a highly energy efficient way to preserve stored carbon? And so Amber and I, as running this research nonprofit, we're in the process of conducting experiments that would set the stage, provide the proof of concept, so that the world could look at biomass storage and say, okay, this is something that could work. And as a nonprofit, all of the research is open source. So like a nonprofit can get a patent, I suppose, but we would never charge people for those patents. And if we write papers, we collect data, we'll just put it all on our website. We actually want people to take our results, take what we learn and use it to build a biomass storage industry, something that could be profitable. Because we view that there's something of a research gap right now. That right now, biomass storage is an okay concept, but it doesn't exist as a business. And normally what would fill that gap is academic researchers doing their thing in university, but they're not doing it for some reason. So our goal is to kind of bridge the gap, connect the business world with what's possible scientifically. Now, where do volunteers fit into that? I'm not too sure, to be honest. I think when I wrote my spiel for volunteers for Exaquest, I said, if you believe in this and this is something that resonates with you, we could find a way for you to help. I'm trying to remember what I wrote. Like we could use scientists. Sorry, go.
Well, that might be a great segue. Like, why don't we have people who, fellows who are here interested in volunteering, introduce themselves and like what they are interested in, like what part of Exaquest excites them, or what type of like skills you want to personally use, and maybe that's now we can start ping ponging back and forth.
Excellent, excellent. Let's go for it.
Also, feel free to drop in any questions into your intro. I imagine John put out a lot of teasers, so I imagine there's lots of questions.
Sure. Who wants to go first? Well, I guess I'm curious about you guys, so I'll just go clockwise on my screen. Like Miranda, can you tell me about yourself, what you do?
I am Miranda. I actually spent the last decade living and working in Dubai, while working with different startups and in the ecosystem, developing the ecosystem. So I guess I come from a bit of a product operations and a bit of marketing background. And the last year I've been trying to explore what I can do towards climate. So I've been engaging in various projects, not specifically nonprofits, but various types of engagements within the space, seeing how I could apply my, I guess, more marketing skills for that, and like more, I guess, product development aspects, and just interested to just learn more about different companies like yourselves, and just see how maybe there are ways to apply the skills I have to help companies. So.
Very cool. I'll just say that we could probably use somebody who has some savvy in marketing at some point, because Exaquest is operating outside the typical scientific community. Like, we're not getting grants, the way scientists typically get grants. As a nonprofit, we can raise money from the general public. And in order to do that, you need a pretty slick marketing operation. Like, you need a way to connect with the general public. Like, I could easily see you being like the most important person on the team if you decided to join. Let's continue.
Sure.
Samantha?
Hi, I'm Sam. I'm part of the core team with Climate Fellows. So here more in a capacity to run and support Climate Fellows, but my background is in tech, startups, project program management. I think what you're doing is amazing, and yeah, thanks for sharing. I will keep myself available, and I will pass it on to the next one.
Okay. I'm just going from my screen. So Camille, the next one.
Hi, I'm Camille. I use they, them pronouns, and I am coming to you all with a tech background, primarily in software engineering, and that includes full stack, so back end, front end, and then I also have experience in product management. And so I'm looking to offer that skill set as either a technical advisor or helping to support any technical work. And then also happy to help support thinking through product development and things like that. Yeah, I think that's pretty much it for me.
Cool. I'll just say on the software side of things, like right now, it might not seem like Exaquest has any need of software, but in the past, we've thought about how would you make a business out of biomass storage? And actually, technology becomes a very important part of that, because in each of our daily lives, I'm assuming, come into contact with some biomass. Maybe you have a yard, or you live in an area that has parks nearby. If we were to try to collect biomass at scale, something like an app or some kind of tracking tool would be extremely helpful, because you'd want to quantify what's being collected, maybe like assign credits to people who bring the biomass so it can be stored, that sort of thing. So I wouldn't say it's like exactly what we're working on right now. We would never say no to somebody with software skills. And our website is terrible, so apologies if you guys visited the website. Like, I built the website. I don't know anything about tech, so it's probably pretty obvious.
Also, I would add, just on the note of biomass storage. So I also live on 25 acres of oak woodland. And we just had fires come through a couple of years ago, and I'm seeing a lot of biomass in terms of fallen trees, or even, it's wine country. So I see a lot of vineyards burning a lot of their biomass. So I'd be very curious to have conversations around supporting like biomass collection, or just offering connections around working with land managers directly.
Yeah, one of our biggest needs is just having a place to conduct an experiment. So right now, Amber and I had a mutual colleague at Stanford. He lives out in Nevada City, which is kind of in the Sierra foothills. He owns a few acres, and he has let us come out to his property where we have begun setting up our first biomass storage experiment. But it's 4 hours from San Francisco to Nevada City. So it would be awfully nice if we had a place to conduct an experiment that was a lot closer for Amber and myself. And that's maybe I'll reach out to you separately offline.
Please do. Sounds great.
Keenan, I think, is the next one.
Yeah, hello. It's so good to meet everyone. Yeah, I guess my background, I'm coming to you from Seattle, Washington. So I'm up in the Pacific Northwest. I am a recovering Bay Area person as well, because I was there before this. But I sort of started my career in aerospace. I worked in the aerospace industry for a long time. I was living in Los Angeles, worked at SpaceX for quite a long time. I wanted to work on climate. I had no idea how to do that. So I sort of entered the climate startup world for a really long time. And I founded like an electric aircraft company startup. And I did a lot of work in like hard tech and like manufacturing kinds of things. I think one of the things that's really interesting to me about Exaquest is the ocean storage component. Like one of the startup I was most recently at before my last job was to use autonomous submarines to map the floor of the ocean. Really? And kind of my personal interest in that was like, I had a very dumb idea at the time, I think, but it was like, okay, like we don't know how to make the business model of like CO2 capture profitable. So like, if it's not going to be profitable, like what's the easiest way to just store it? And I was like, we should just build like domes underwater and just store it in the ocean as like the easiest hack, and then hope we can monetize that later. I think that's a bad idea, but I just wanted to like learn about the ocean. And I think your idea is much smarter than that idea, but it was like super interesting.
So you were going to build a structure to hold pure CO2 in the ocean?
Yeah, well, that was like kind of my silly idea, because I was like, well, it's easy structurally to do that underwater compared to like above land. And I was like, all right, like, is that possible or not? So anyway, but I think like the idea of ocean storage has been super interesting to me for a long time. And I think the other part that's really compelling to me is the nonprofit model. So I was just on staff at a climate tech accelerator. And so I got to see 50 climate tech startups as a part of like, I'm sure you guys know RMI. They have a climate tech accelerator now. And the business model of carbon capture is tenuous at best. Like it's really questionable to me, like whether it's responsible to create a for-profit business doing anything of the sort. And so I think like, anything in the nonprofit space is super interesting to me in that regard.
Well, we're at an interesting point where there's definitely capital that's going to the for-profit startups. You can definitely make a PowerPoint presentation that shows like revenues go super high in year 3. But the reality probably hasn't caught up yet. And I feel like this goes to Exaquest being a nonprofit. Like Amber and I saw a lot of people going down that road. We were at Stanford. And not to say that like for-profits aren't a good thing, but like it leads you into a certain mindset. So like you've got your technology, right? You're developing it. But if you're a for-profit startup, you can't say anything about it until you have all your patents locked up, right? And so you're constantly worried about somebody stealing your ideas and all that. Like it's a shame, because you might have like 6 companies that are kind of all working on the same thing, but it's going to take $100 million of capital for each company to get there. Maybe none of them get there. So it's like 600 million down the drain, where if they worked together and shared their results, maybe they might have solved the problem. So like Exaquest is coming at it from the point of view that maybe a more collaborative approach is going to yield better results. So we're very happy to share with people. We're hoping that people copy us. We want to inspire scientists and policymakers to kind of take what we're saying seriously. And we would welcome any criticism. So if we do it wrong the first time, it's like, by all means, please criticize us so you can do it better. You know, that would be very nice. But yeah, I love your hard tech background.
Totally.
If we ever, you know, get to where we want to be, like, we would need tons of people like you, so who can build things. Okay, and Espoir is the last one on my screen.
Hello everyone, my name is Juar. I come from Togo. Togo is a small country in West Africa. Small country, but I'm working in Dakar, Senegal. Yeah, so I'm agronomist and I'm working on the agriculture projects. Right now, I start my PhD on modeling approaches on vegetation climate interaction in some agroforestry systems. So I'm working right now on 3 decovariance tower. It's some kind of a system. We get each 10 minutes data from our system. Here is some plots we set up in our area. So we have a deep pit to study, for example, root dynamic with automatic scanner, mini risotron, and we have some automated salt chamber or CO2 to understand how our system contribute to GHG at global scale. So we use a modeling approach we develop with University of Amsterdam, some colleagues coming from France to understand how we can develop some system or some techniques to mitigate climate change in West Africa.
Cool, very cool. I suppose there was going to be 10 minutes for Q&A, so you guys should ask any questions that you have about us.
Okay, I had a question. As I asked you last time, do you think that in our area, as I said, we get a real problem of biomass storage? For example, in Senegal, many people grow peanuts, and as peanuts is the main crop, they just take everything, like leaves, groundnuts, everything for their just to feed livestock and for their survival. So anything there was anything after the rainy season at farm. So we have many problems like soil erosion, for example, and we have no capacity to stabilize soil, for example. So we try to use some technique, but we got a very problem. So what do you think that are you really sure and a long term, do you think that is very I don't know, efficient to bring as you say biomass from wet area, for example, to our area? In terms of cost, do you think that as our research here is funding from USAID, European companies, do you think that we can support this if your method will implement?
You're asking a really good question. Basically, like, how practical is this? Like, when you get to nuts and bolts and collecting biomass and moving it, like, can it work? I think, you know, Amber and I have always thought that the agricultural type of situation, you know, where you're growing crops and you have your ag waste, that's maybe the most challenging type of situation for something like Exaquest, because agriculture is all about like fertilizer inputs, food outputs, and it's a pretty finely tuned system. And when you move biomass, especially when you're not talking about woody biomass, you're just talking about leaves and stems and stuff like that, you're moving a lot of nutrients too. That's something you have to account for. And I would say on our research agenda is a big item for nutrient extraction and recycling, but that's a technology that's very far down the road in terms of what is possible. So I would probably not suggest this as something for, your residues from like a peanut farm. But if you're talking about just a forest where trees are regularly dying, or maybe there's a disease that goes through a forest, or a drought kills a bunch of trees, to me that presents more of an opportunity. And in California especially, we have this problem of overgrown forests, and when you don't remove the fuels from the forests, you get these bigger fires. That's something that people want to do anyway. They want to take trees out of the forest for safety reasons. And then that raises for us an obvious opportunity. It's like, well, if you're removing the trees anyway, why don't you put them into some kind of storage instead of letting them rot? Another question.
So I guess you said you're looking to run some experiments in the short term as kind of your first goal. Maybe you could speak a little bit more about like what those are, and is there any opportunity for like the group here to help you out on those experiments, or not?
Well, let me see if I can share my screen, because I just updated our website a little bit of this. Let's see if this is permitted. Oh, disabled participant screen sharing. So maybe I can't. Oh, there we go. Okay. So share. Do you guys see this page from our website?
Yeah.
Okay. So Exaquest's first experiment. A little bit of text. Our collaborator in Nevada City is a chemist, Dr. Arnold Foreman. We've written a document that describes what we're doing. So that's the link there. And then let me see if I can zoom out a bit so you can see this a bit better. So does that show up okay? This is essentially our first experiment. So what you're seeing is a water tank sitting on a pallet, and then we have a very kind of low-tech way of lifting it. And what we're planning to do is to take wood chips and put them in the tank, to put in like system or version 1.0 of our airflow system to remove water, and then track the mass of the system. So we'll be able to tell if we're removing water. We'll have sensors inside to tell us what the temperature and the moisture content of the wood is. And then the hope is that when we reach a certain condition where the wood is dry, we'll be able to confirm that nothing is happening. That's the obvious goal of biomass storage, is for nothing to happen. I think there's another picture here that's more zoomed out. So these straps are about 25 feet up on these trees. So actually, I went to Nevada City about a week ago to do this work. We got up on big ladders and we attached all this stuff, and it was kind of fun, a little scary. But yeah, this is a real deal experiment. We're probably going to be able to put 400 to 500 kilograms of dry kilograms of wood chips in that tank, and if it stays stored, then that's about 700 to 800 kilograms of CO2. That's just not going anywhere. Let's see. These are our wood chips. I can kind of zoom back in for this one. So a neighbor of our collaborators, he had some trees that he wanted to take down. So he just ran those trees through a chipper, and that's our raw material for the first experiment. And we have these sensors that we purchased. They're like temperature humidity sensors. They're pretty small things, like 1 inch by 1 inch. But we put them inside a protective cover. So we take some PVC pipe, we drill some holes in it. So obviously it can sense the environment, throw the sensor in, and then you protect it. You take some garden wrap and you throw this in the pile. So obviously there'd be much more to talk about in terms of like, what does the experiment look like? But I think that's hopefully that gives you a rough picture. And I see it's 3 o'clock, so maybe, yeah, you have to hop off. Does that mean we have to stop the meeting?
I have to hop off, but let me try to transfer host to you, John.
Okay,
Let's
okay.
see.
Maybe that will work.
Okay, it looks promising. Okay.
Okay, I'm the host now. So anybody who wants to stick around, looks like we lost a few people, but that's okay. So Espoir and Keith, I think you guys are the ones who stuck around.
Sure.
Yeah,
I guess in those experiments, is there any, like what sort of help do you all need in doing the experiments, if any? Like maybe you have it covered, I'm not sure. But
we absolutely don't have it covered, by the way. Like, so like I live in downtown San Francisco, so I obviously can't do a biomass storage experiment very easily where I live. Amber lives in Cupertino. It's like suburban Bay Area. It's not easy to do something like this. So in order to do this work properly, you have to kind of get out where there's some space. So just, and somebody who has the type of equipment that's necessary. So it was just luck that we, became friends with this guy, Arnold Foreman, and just luck that he was interested in helping us. Obviously down the road, it would be nice if we ran into more people like Dr. Foreman. So, we can do more projects like this. That's kind of the sticking point. It's like, unfortunately, where Amber and I are, it's hard to do this kind of work. And then when you bring in a collaborator, you have to rely on them quite a bit. So I feel guilty sometimes. Like I'm asking Arnold, like you need to go out and like fiddle around with this equipment. You need to send us some data, things like that are just kind of like what you would ask like a grad student to do. But I think hopefully we'll get people excited about this. Maybe we'll have more volunteers. So yeah, that's kind of that's the challenge of an above ground experiment. Now you had expressed interest in a below ground or underwater experiment, and that is a whole different box of cherries. It's like it's okay. So this is our vision when it comes to storing things underwater. It's like your typical terrestrial biomass, and we're focusing on terrestrial biomass, right? There are people like Running Tide and people who are focusing on algae. So there's this concept out there that you can grow algae and sink it to the bottom of the ocean. And I don't think that's a terrible idea, but I think that there are some very real challenges. I mean, you've worked in the ocean, so it's not super easy to have a floating platform that's going to grow all this algae and to do that at a huge scale. So I think since we're a land-based species, human beings are on land, this is where we're comfortable. It's easier for us to collect biomass on land and then overcome the challenge of making it heavy enough to sink. Because normally, like a log, for example, will float on water. It's less dense than water. So you need to somehow make it more dense or waterlog it, cause it to become waterlogged so that it sinks. And that to us, that's just an engineering challenge. Like Amber, am I overstating how simply we view this?
No, I mean, and there are examples of, cases where this has happened sort of unintentionally. Like there's several examples of logs from the 1800s from the logging industry that I don't know how they got in the water. I forgot that, but they have sunk to the bottom of like Lake Superior. And there's a couple of other examples too in the United States besides that. And they're still there, just pristine, perfectly preserved. So there's kind of unintentional demonstrations kind of scattered out all over throughout the world. And it is really kind of that simple. If we're going to use something besides a straight up tree, then we may have to densify it first. But yeah, I mean, it's not rocket science.
Yeah, I can give you the backstory of why this happened. It's back in the day, right? People were just logging, right? You had like your lumberjacks out in the forest, and imagine it's like the 1850s in Wisconsin or like Georgia or somewhere, and you're just like chopping down trees, right? Because you want to sell wood. Well, the easiest place to store the wood, to store the logs, was actually in a lake or on a river. Like if you wanted to move the logs from like one point on the river to another point downstream, you didn't use a boat. You just like literally pushed the logs out into the water and it floated down. Well, in certain places, they did that so much that some of the logs became waterlogged. Like there were just these jams that appeared, maybe like in Lake Superior, for example, which is next to Wisconsin. They were just pushing the logs into the water, and some of them sank. So it's possible to create these conditions where a log becomes so heavy that it sinks. And something that Amber and I are interested in exploring is like, maybe it's not practical to take a log and be 100% sure that it's going to sink, but maybe it can take on enough water that its density increases by like 50 or 60%. And then its buoyancy is much reduced, and it would be much easier to attach weights to it and sink it. And that's a scientific question that I don't think there's a lot of knowledge, about how to do that. And so, yeah, we're just curious, because the energy advantage, this is something we always talk about. It's like our approach to carbon storage. Like the energy advantage of the method we're proposing is huge. It's like on one side, you can have a direct air capture plant, which is consuming all this energy. And on the other side, you could have an operation where you're just collecting logs and then either sinking them or storing them above ground. Like you're going to consume much less energy when you're storing wood or sinking wood. And it's just, if we could figure, like, that's what's so exciting. It's like, if we could figure these things out, it's like lots of things become possible. And it's like, for example, we're also in the X Prize. You talk about having worked for SpaceX. Like we have a team that's in the X Prize. We're going to submit a demonstration, see if like we can actually, present ourselves as one of the better approaches.
Yeah,
anyway,
but super interesting. Yeah, and I'll definitely keep that in mind. Like I know a lot of startups in the Bay Area who are at varying stages of like a kind of common strategy, right? Is like you buy out a whole building and then convince yourself that you're going to sublease the other half because you can't actually afford the whole building. And so like I'll put my feelers out for people in the Bay Area who might have some space that you all could like set up, maybe in like half of a shop or something.
I mean, that's something that would be extremely useful, because actually we don't have a ton of money in the bank, but we do have money. Like, so if we had a spot where we could rent, a reliable space, for a reasonable cost, we would consider it.
Yeah, and maybe there are some people, like a lot of people just have empty space that they're not using yet, and like I'm sure some of them might be willing to donate or like let you guys set up there for a while or something. So I'll put my feelers out and see if anybody is like, if I find anything, and definitely shoot you all a note if I find anything that's promising. Yeah,
I really appreciate it. I appreciate it. What are you working on now?
Yeah, so I just left the accelerator, and I don't know exactly. Like I'm kind of like figuring out what my next thing is. I'm working on a project right now, which I think is actually like super important. And I'm trying to figure out like if that can be sustainable for me or not. Like I've won a few small grants, and like I'm seeing if I can win a few larger grants that could kind of make it sustainable. But like one of the things that I've been super like aghast at is just how little data we actually have on like what the CO2 emissions of the world are and like where they are. We have basically no data. And from my aerospace background, most of the solutions that have been proposed realistically are from satellites in space, which is one, it's the most expensive possible option. And then two, there's still no way to like truth that data. So we can't say canonically like that this is correct because we have no truth source for this. And it's possible, like deploying a network of like ground-based CO2 sensing is doable from the engineering perspective. It's super feasible to do. And like, I think we should do it. There's been like some decent academia progress on like, hey, this works. Like they've done this in Munich and then at Berkeley. And somebody just needs to take it out of the university lab and like deploy this more widely.
Yeah.
I don't think it's a for-profit business because you would have to monetize the data set, which I think is wrong.
Oh, yeah.
So I'm trying to figure out like, what does that look like? Because I've already built like a couple of the sensors here for myself, and I'm trying to decide, like, is that a nonprofit ultimately, or is it a B Corp that is just extremely unprofitable and can get bootstrapped all the way up? But that's the project that I'm working on that I'm really excited about.
Well, I'll give you a sort of some insight into the nonprofit world, which is that nonprofit doesn't mean no revenues. Like it is possible for nonprofits to have very significant revenues and basically profits. It's just that those profits can't be, they don't become the property of anyone.
For sure.
It belongs to the organization. So, you know, you could monetize the data set, and then the revenues you get from selling the data support your mission. That's like a business model that I think actually makes sense. And I think you could actually set up a very steady, sort of rock solid nonprofit that's based around that concept.
One of the things I'm trying to explore now is just, is the hardware aspect of it profitable enough standing alone? Because like what I think should happen is, like, I've built this sensor, I want to kind of sell it as a kit to people who like want to do something about climate, which I think is a quite significant number of people globally today. And like, is that sustainable or enough? So I'm kind of playing around with, you know, I'm building the technology right now, but then also like playing with the business model and trying to see like, what does that look like in the long term?
It's tough. Yeah, no, we definitely sympathize.
Yeah. So, yep. But that's what I'm working on, is just CO2 measurement. Oh, I think John is frozen. For me, at least.
Yeah, he's frozen. Now he's gone.
Cool.
So, yeah, I guess we have another meeting actually soon.
Okay.
But oh, you do? Okay.
Yeah.
Cool.
But what were you going to say though?
I was just going to say another thing. I think there's a second story to Exaquest besides just our technical, our technical vision, which is kind of how we got to be nonprofit and why we are looking at something that no one else is looking at. The story of why no one else is looking at it is very interesting as well. And it's not just that it can't be a business model, but it's because academics and experts aren't excited by it. And so the people in business that are looking to those experts aren't hearing about the idea. So it's not like it's an idea that was shot down and we're saying, oh no, wait, look again. It's like, we're not trying to say, oh, the earth is flat. We're saying no one ever tried to see what shape the earth was in the first place. So anyway, but we do have to go, but it was really nice meeting you.
It was great to meet you both as well. Pass on my regards to John. Like, for sure, if I can ever help you out, let me know.
Okay. All right.
Yep. See you later, Amber. Nice to meet you.
You too.